So physical impurities that we are going to see in this lecture. So we have seen the classification of impurities based on the size, based on the nature, and the third one and the last one is the based on states of matter or the states of impurity. So among the states, the first we are starting now, that is the physical impurities. Now among the physical impurities we have the five subheadings. The first one is temperature, then color, turbidity, odor and taste. Now the first one will start, that is temperature. Now the temperature of water, okay, the temperature of water is also a very important part in all the design considerations. A temperature is, if it is low, then it can react, or we can say it can cause some effect on the reactions. Also the temperature can lead to the growth or decrease of microorganisms or pathogens in the water. Okay, other than this also, if the temperature of water is less, if the temperature of water is less, that means the water is very cold, then the people who are having some dental cavities or some problems with the teeth, they won't be able to drink it directly. Okay, so rather than transferring the water at a very low temperature or very high temperature, based on the needs of community, certain design standards has been given. So these all design standards of impurities are given in the GOI manual. So I will attach the link in the description of this video. So this manual contains all the impurities and what are the design standard specifications for the impurities. Now let's take the example of temperature. So for temperature, the drinking water standard, the drinking water standard that is specified is 10 degrees Celsius to 20 degrees Celsius. Okay, so the temperature of water should be something between this range. Okay, it should not cross this range. If it is crossing, then you have to do certain arrangements to either increase or decrease the temperature. Now what are the various effects of temperature? So the first effect and the major effect of temperature will be on the growth of microorganisms. Growth of microorganisms in water. Now, so the growth of microorganisms in water, it is directly proportional to temperature. Okay, this symbol here, this stands for directly proportional. Okay, there may be some viewers who don't know, for them I am writing it. So those you know, it's very good. Now what we can imply from this relation? The first thing that we can imply is, if the temperature increases, what will happen? If the temperature increases, then the growth of microorganisms will also increase. So it will increase the growth of microorganisms. If the temperature decreases, then it will decrease the growth of microorganisms. Simple. Okay, so you can see now this relation is called as direct relation, hence we call it as directly proportional. Now this was the direct relation. Now one more we will see, and that is about the viscosity, that is viscosity of water. Viscosity of water. So this viscosity of water is inversely proportional to temperature. Okay, it is inversely proportional to temperature, or we can say directly proportional to 1 by temperature. So what we can imply from this? If the viscosity increases, okay, first thing, what do you mean by viscosity or a viscous liquid? So you just, whenever this term comes viscosity, you just imagine the honey. Okay, so how or what is the characteristics of this honey? this honey flows very slow. Okay, the flow of honey, if it is dropped from somewhere, it flows very slowly if you compare it with the water. Okay, so this resistance to flow quickly, this resistance to flow quickly is called as viscosity. Resistance to flow, this is called as viscosity. Now if there is more resistance, then we can say that viscosity is more. Now based on this, if I ask you, is the viscosity of water is more or is the viscosity of honey is more, then what will be answer? So you can write it in the comment box. Now coming back to the main point, now this viscosity of water, okay, that is resistance to flow of water, it is inversely proportional to temperature. That means if temperature increases, if the temperature increases, then the viscosity will decrease. There will be decrease in viscosity. Similarly, if the temperature decreases, then there will be increase in viscosity. You can see now how is the relation. This relation is inverse relation, hence we call it as inversely proportional. Now the next one is chemical reactions. Chemical reactions. Now these chemical reactions are directly proportional to temperature. That means if the temperature is more, then the amount of chemical reactions will be higher. So same thing we can imply from here. If the temperature is more, if the temperature increases, what will happen to the chemical reactions? Chemical reactions will also increase. If the temperature decreases, then there will be decrease in the chemical reactions. Now these 3 points are very important. Okay, so based on the temperature, you should be able to identify what type or what will be the effect in the water. Let's say I am saying that the temperature is increasing, so what will happen to the growth of microorganisms? The growth of microorganisms will also increase. What about the viscosity? The viscosity will decrease. What about the chemical reactions? The chemical reactions will increase. Okay, so this is a conceptual understanding of the temperature of water. Okay, now other than this, the most important thing that you have to remember exam point of view is also this range. That is, what is the standard range of temperature for the drinking water? So what should be the range? 10 degrees Celsius to 20 degree Celsius. Now one question I want to ask you, and I want you to search that in a cold countries, okay, in cold countries, what do you think, how the water is transferred or transported from the water treatment plant to the individual community? So if you take an example of India right now, then in India the temperature is, you can say that it is a normal temperature. We don't have here ice and all, but where the temperature is below 0 degrees, there is complete freezing of water. So under those conditions, how the water is transferred to the home? Okay, so you try to get the answer and post it in the comment box.